Hello, this is the third in a series of videos addressing the installation of Cisco Modeling Labs version 1.2. In this section, we will prepare the ESXi host for the Cisco Modeling Labs deployment. We will start by reviewing the security modifications that will enable a command line interface to the ESXi host. We'll follow that with a quick demo affecting those changes. Next, we'll review the network connectivity requirements for our deployment and the ESXi configurations necessary to match those settings applied to the access switch in our first video. We'll then follow that review with a demonstration that prepares the ESXi's networking configuration for our installation of Cisco Modeling Labs. By default, ESXi has its CLI disabled, limiting access to either the vSphere client or vCenter management station. Enabling CLI access is necessary to allow Cisco technical support members the ability to access the hypervisor environment should the need arise. There are two ESXi security profile settings that may need modification as to enable CLI access to the host. These will be set active when the ESXi host is operating. In this demonstration, we have used the VMware client to log into our ESXi host that has been freshly installed. Clicking the Summary tab, we can see the host's attributes. This machine is a Cisco UCS C220 M4 server, a 2-socket version fitted with 12-core, 2.5 GHz Xeon CPUs. This yields a total of 24 cores. Note that the hyper-threading option is active. The summary reports 48 logical CPUs. This number should not be used to forecast CML capacity. Only the actual core count is relevant. Checking the image profile shows we're running ESXi 6.0. Cisco Modeling Labs has not been formally tested for vMotion, and it is not recommended. If advanced VMware features are part of standardized host setups, be aware that enabling EVC mode can inhibit CPU features required for CML operation. Looking at the resources pane, we see that 24 cores are reported and the host is fitted with 192 gigabytes of RAM, and we have 1 terabyte storage provisioned. To set the security options, select the Configuration tab. Within the software pane, clicking the security profile will show the services and firewall settings. Click the properties associated with the services section. Single-click the ESXi shell object to highlight it, then click the Options button. If the process is currently stopped, click the Start button, and then set the startup policy such that the process starts and stops with the host. Click the OK to return to the Service Properties window. Repeat this same process for the SSH service. With secure shell access to the host hypervisor enabled, we can move on to the networking aspects of the ESXi environment. In our deployment, we will add the CML management interface to the same address space used for the ESXi management. This will utilize the same connection. The ESXi host sees this interface as VMNIC0, which is associated with vSwitch 0. This vSwitch was set up during the initial ESXi installation. When we deploy the CML OVA image, we will map the CML's management interface to the VM network port group. Within the access switch, we defined an 8021Q trunk to carry the other external communication interfaces within their respective VLANs, as listed in the table. In configuring the ESXi networking, we will add vSwitch 1 and associate it with the VMNIC1 that terminates the 8021Q trunk from the physical switch. vSwitch 1 will have the remaining 4 port groups labeled as expected by the CML OVA image, with each associated to its respective VLAN ID. With the 4 port groups defined, we will configure the vSwitch to operate in promiscuous mode, with each of the included port groups inheriting this option. Returning to our ESXi configuration, Select the Networking option within the Hardware pane. We see our vSwitch 0 is attached to the server's Ethernet 0 port. This is supporting our current ESXi management connection. It will also support the CML management interface as applied by our OVA image. To prepare for the remaining network interfaces required by Cisco Modeling Labs, we will add another vSwitch by clicking the Add Networking link. This will invoke the Add Network wizard. Select Virtual Machine Network Type and click the Next button. For the network access, select the VMNIC1 for the uplink adapter and click Next. This will progress to the Connection Settings window. In the Port Group Properties, enter FLAT as the network label. And 101 for the VLAN ID. The preview window will indicate your edits. Click the Next button followed by Finish in the summary page. This completes the wizard with the new vSwitch 1 appearing in the Networking Summary display. 3 more virtual interfaces must now be added to this vSwitch to account for the remaining VLANs. Click the properties associated with vSwitch 1. In the vSwitch Properties window, click the Add button. In the Connection Type window, select Virtual Machine Network Type and click the Next button. This will progress to the Connection Settings window. In the Port Group Properties, enter FLAT1 as the network label and add 102 for the VLAN ID. The preview window will show the additional port group associated with vSwitch 1 using the entered parameters. Click the Next button followed by Finish in the summary page. This process is repeated for the 2 remaining port groups named SNAT and INT. When all 4 port groups have been added to the vSwitch, their security policy must be set. While still in the vSwitch 1 Properties window, select the vSwitch object. With the vSwitch object highlighted, click the Edit button. In the pop-up window, select the Security tab. In the Promiscuous Mode option, select Accept from the pull-down options. Click the OK button. By selecting each of the port groups in the vSwitch, we now see their security policy is set to accept promiscuous mode operation, passing traffic to the virtual machines behind the vSwitch. This completes our preparations to the ESXi host. Our next module will install the Cisco Modeling Labs virtual machine. In this module, we reviewed the ESXi security settings with the corresponding demonstration. We then reviewed the ESXi communication settings necessary for the Cisco Modeling Labs with the corresponding demonstration.